3U Quadratics Day 2, determining the maximum and minimum values. We have three forms of the quadratics that can help us find various key features. This will behave for me. There we go. Maximum or minimum values, as in maximum area, maximum height, maximum profit. Those are all really key, or minimum production costs. X-intercepts, or the roots or zeros or solutions to a quadratic equation. All the same thing. And y-intercepts. We also talk about axis of symmetry and whatnot. Let's mark these on the graphs. A quadratic equation graphed as a parabola can open downwards. And in that case, we have a maximum value, which is the y value of the vertex. The vertex is that point, turning point in a parabola. The axis of symmetry is that fold line that goes down through the middle, goes through the vertex, always has the equation x equals, and it is the x value of the vertex. Y-intercept can be very important as well. And the x-intercepts. In this case, there are two. This particular parabola, though not well drawn, opens upwards. So it will have a minimum value, which will be the y value of the vertex. My vertex. Here's that we have two x-intercepts and a y-intercept here. We're not always given, quadratic equation in vertex form to draw it quickly and easily and find these key features. We need to do some algebra to go back and forth between the different types of equations in order to solve problems. Y equals ax minus h squared plus k is vertex form. The easiest thing to find is the vertex. It comes from the h value and the k value, the left and right translation, the vertical translation, up and down. Therefore, it is easy to find the axis of symmetry. It is always x equals the h value, being careful of your lefts and rights. The y-intercept we can find by setting x equal to 0 in this form. It's the x-intercepts that are a problem. They are not immediately obvious in this particular form. Oh, one last thing we should probably mention is that the vertex will give us our max or minimum value, depending on whether it opens upwards or downwards. If it opens downwards, you have a maximum value. If it opens upwards, you have a minimum value. So we have found many of our key features when it is in vertex form. It's x-intercepts that are a problem. For factored form, as you can see, it's in two sets of brackets looking like a multiplication. That is considered factored form. The easiest thing to find in this form are the x-intercepts. Two x-intercepts. One of them would be the A, one of them would be B. If we're not sure about the sign, we get those x-intercepts by setting x minus A, whatever you have in that bracket, equal to 0, and solving, and that will give you your first x-intercept. The second x-intercept would be the other bracket, set equal to 0, will give you your two x-intercepts. Y-intercept sometimes I just don't know what happens to this stupid thing. Okay, there's the x-intercepts. I think I was talking about the y-intercept. As above, we can get the y-intercept by setting x equals to 0 throughout the equation, and we can find our y-intercept. The axis of symmetry and the vertex and the maximum and minimum value are a little bit trickier. The vertex can give us all of those things, but it is not immediately obvious looking at this particular form. Our vertex can be found, however, by averaging the x-intercepts. If you have a parabola with x-intercepts, there we are, here and here, your vertex will lie right in the middle of those two x-intercepts. That value must be in the middle, and we can find middle quite easily by averaging. That will give you the x value of your vertex. To find the y value of your vertex, you would sub that number into the function and solve for y. So for this particular form, we can find everything. It just might take us a bit of work to get there. Lastly, general form. Y equals ax squared plus bx plus c. The only thing that is immediately obvious in general form is the y-intercept. If we set x equal to 0, which is the way to find y-intercept, we would be left with just the c. And there we stop. All of the other key features are more difficult to find in this form, which means we need to alter it and put it into one of the other forms to find the key features. We mentioned yesterday that going from this form to this form, which would allow us to find all of the key features, we would have to factor. Conversely, to go from this form to that form, we could expand. And lastly, to go from vertex form to general form, we would expand. Hope my arrows aren't confusing you. And lastly, if I want to go from general form all the way to vertex form, which is so easy to see our vertex and therefore our maximum and minimum values, we have to complete the square. So that is our goal, to do some algebra today to get some of our key features. If we have a function in one of the forms that's not easy to find our key features. Let's expand. I'm not trying to treat you like you're silly. Let's assume that is hard to remember. Okay. If I'm going to expand, I am going to do the distributive law gone wild. We use an acronym for that called FOIL. If I'm going to FOIL, I do my firsts, which is x times x, outsides, which is 5 times x, inside, which is minus 4 times x, and lasts, which is minus 4 times 5. Simplifying it to put it into the form we are used to, a trinomial, put my two x values together, I have 1x. You can write the x or not, write the 1 or not write the 1. And we have gone from x-intercept form to general form. So in the first y equals x minus 4 times x plus 5, we can state that the x-intercepts are 4 and minus 5. And when we have it in general form, we can state that the y-intercept is minus 20. We could do the work to find the vertex as well from our two x-intercepts, but let's continue practice expanding. The second one, y equals 2x plus 1 times x minus 3. It will be the same idea. We have to do FOIL. Y equals firsts, give me 2x squared. Outsides give me minus 6x. Inside is 1x, and last is minus 3. Simplifying by collecting like terms, I have 2x squared minus 5x minus 3. My y-intercept is minus 3, and my x-intercepts are 3. Let's write them over here. X-intercepts. The one bracket, the second bracket is a little easier to see. The one x-intercept is 3. The second x-intercept is minus 1/2, because if I solve for 2x plus 1 equal to 0, I would get, subtract 1 from both sides, x equals minus 1/2. This is a little bit of review and we will look at it in more detail, but I have obtained my 2x intercepts from factored form. All right, third one. We have 3 things being multiplied. We can only do 2 things at a time. I would do those 2 first and then multiply by x minus 2 in a moment. So my next line would be distributive law. Minus 3 times x plus 6 is minus 3x minus 18, and then I will multiply by x minus 2. It doesn't matter. If you wish to do the FOIL first on the 2 brackets and then deal with the minus 3, you would get the same answer. I'm going to FOIL now. I will get minus 3x squared plus 6x minus 18x plus 36. Collecting like terms, minus 3x squared minus 12x plus 36. I can tell from the minus 3 at the front of both of these equations that my parabola will open downwards and be skinny because it's got a vertical stretch factor 3. I can tell from the first form in factored form that my 2x intercepts are minus 6 and 2. My y-intercept from the other form would be 36. The next one is in vertex form. I can tell from this form that my vertex would be 3, 7. Very helpful for graphing. I also know, because there is an invisible one right here, that it is right side up and regular step pattern. I could graph that quite easily. To write it in expanded form or general form, I need to do a FOIL on this, but be careful. To expand that to general form, I need 2 x minus 3's, because that's what square means. Add 7 at the end. If I do FOIL on those 2 brackets, I get x squared minus 3x minus 3x plus 9 plus 7. To simplify by collecting like terms, I have an x squared, I have minus 6x, and a 16. That tells me that my y-intercept is 16. And the last one on this slide, also in vertex form, which tells us that we have a vertex at 4 to the right, 3 up. I also know that this parabola, if I were to draw it, would open upwards and have a step pattern altered by a half. So it would be wide, open upwards. It will have a minimum value of 3. To put it in an alternate form, however, I need to expand. So I have a half. I have 2 x minus 4's that I will have to FOIL and add 3 later. I would deal with the half last. I would do FOIL on this one first. I'm not sure I can tell you why, but let's do it. X minus 4 times x minus 4 is x squared minus 4x plus 16 plus 3. Now order of operations would say I should do the half next. That means everything in my bracket will get multiplied by a half. A half x squared minus 2x plus 8, then plus 3. Tidying it up, I get y equals a half x squared. Again, indicating that it is opening upwards with a wide look to it because my step pattern has been compressed, factor 1/2. I missed an x in here. All right, my x's will give me minus 4x. And my y-intercept, 8, 9, 10, 11, is what this particular form gives me most easily. Lucky for us, we've spent some time factoring already when we did rational variable expressions. So as a short recap, when we are factoring, we look first and foremost for a greatest common factor. Common factoring can save us a lot of headache and make life a whole lot easier. So we look for that first. Everything else that we will factor in grade, am I lying to you, grade 11, will be a trinomial in some form or another. Trinomials are simple, where you have x squared plus 7x plus 12. Your a value is 1. Those are considered simple trinomials because we would factor those by throwing up two sets of brackets and undoing a FOIL, remembering that you need two x's to multiply to x squared. For your lasts, you need to multiply to get a 12. And for outside, inside, they need to add to get a 7. Multiply. There we go. So the thought process should be pretty quick and speedy by now. Secondly, we would look for particular ones like difference of squares or perfect squares. Difference of squares is where you have x squared minus a squared, where x squared and a squared are both beautiful squares. It would factor to x plus the square root of a squared, x minus the square root of a squared. Difference of squares are nice. They are in fact trinomials with a missing middle term. Perfect squares we're not going to write in our summary here because they are unique and you can still factor them in other ways. Lastly, we have more difficult trinomials, but they're trinomials in the form ax squared plus bx plus c, where a is not 1 or 0. We use decomposition to factor those, where we break apart the middle term so that we can factor by grouping. First two, second two, put it all together. We were really good at this. As a quick recap, let's look at the next 4 functions and factor them. Y equals x squared minus 3x minus 10. First thing I would look for is a greatest common factor, and other than 1, there isn't anything larger than that. So I'm on to trinomials. It is not recognizable as a difference of squares or a perfect square. It is a simple trinomial because there's an invisible 1. So I can factor it. Sorry, I didn't write that in good form. So I can write it in factored form as two sets of brackets. I'm undoing FOIL. My two numbers that I need in the back half of my brackets, multiply to negative 10, add to negative 3. Multiplying to 10, I can use 1 and 10 or 2 and 5. 2 and 5 can get me to a 3. And I need to be careful of my sign, that the negative is on the larger to get to a minus 3x. I'm done. Therefore, my x-intercepts are 5 and minus 2, and my y-intercept is minus 10, looking at the two different forms. And from the original form that we had, our y-intercept is minus 10. Y equals x squared minus 49. Looking for a greatest common factor. Other than 1, there isn't one. It is not a simple trinomial. It is a difference of squares. Differences of squares are so lovely. Two sets of brackets, square root of x squared at the front, a positive, a negative, a 7, and a 7. My y-intercept is minus 49. We can picture that one quite easily. It is a parabola that has a vertical translation 49 down. So it makes sense that our y-intercept is there. Our x-intercepts should be balanced on either side of that vertex at minus 7 and 7. Third one, y equals 3x squared plus 2x minus 8. It is a more difficult trinomial in the form ax squared plus bx plus c, where a is a 3. We need to use decomposition to factor this. I am going to decompose the 2x into two parts. such that my two parts add to 2, and, be careful, multiply to minus 24. So my two numbers will go right here. My two numbers could be, for 24, 1 and 24. Never add to 2. 2 and 12. 3 and 8. 6 and 4. 6 and 4, if one is positive and one is negative, will give me a 2 and multiply to negative 24. Order doesn't matter. I'm going to do my 6x first and then my minus 4x second. I've decomposed the middle term. Now I can factor by grouping those two first, and then I'll do those two in a moment. Factoring the first two, I look for a greatest common factor. I see one. It is 3x in brackets. I need another x, and I need to multiply by 2. So we're undoing distributive law. Do a quick check that 3x times x and 3x times 2 is the first two terms that you started with. Secondly, I want to find a greatest common factor for minus 4x minus 8. I also know that in my brackets, I would really like to end up with x plus 2. So I'm going to take a greatest common factor of minus 4 instead of positive 4 so that I can write x plus 2 in brackets. When I have common factored by grouping, sorry, I can't do two things at once, I will collect like terms, which is now x plus 2. I'm sorry, a greatest common factor, which now is x plus 2. And the leftovers, which is 3x minus 4. If you do a FOIL on that, you will get the first line here. So, looking at factored form, I know that I have two x-intercepts of, the first one's easy, minus 2, 0. Second one is a little bit harder. I just keep doing this to practice. 4/3. If I put a 4/3 into that bracket, I will get a 0. My y-intercept from the first form is minus 8. The last one. Y equals 5x squared plus 14x minus 3. It is not a simple trinomial. It is not a difference of squares or anything quite so nice. And there's not a greatest common factor other than 1. So I have to use decomposition on this. I have to decompose the 14x into two parts such that my two parts add to 14 and multiply to 5 times minus 3 minus 15. My two numbers would be 15 and minus 1. So I will write that as y equals 5x squared. I'm going to do the 15 first, but it doesn't matter. It's 15x minus 1x minus 3. Then I can factor by grouping the first two and the second two, keeping in mind my ultimate goal. 5x factors in both, x plus 3, and I have factored the first two terms. Knowing for the second pair that I want to end up with x plus 3 in brackets, I will factor out a minus 1, which allows me to do that. Final answer then would be a greatest common factor of x plus 3. And if I multiply that by 5x and negative 1, I will get what I started with. From the first form, I know that my y-intercept is a minus 3. From my second form, I know that my x-intercepts are minus 3 and 1/5. So going back and forth between factored form and general form is something we're quite familiar with. We can factor and we can expand. It is going from general form to vertex form that can be really helpful and a little bit challenging. This is from grade 10, but it is a little rusty. Y equals x squared plus 4x plus 1, and I want to write it in vertex form. I know what I want it to look like. I want it to look like that. Probably plus a number, Probably x plus a number here, perhaps something here. But I know the form that I want to have. So I want to come up with x plus something that when I square it, I will get something related to that. Well, I'm going to try a 2. X plus 2 squared. Let's do that work over to the side. Y equals x plus 2 squared. I think that just might be it. That would give us x plus 2 times x plus 2, which would be x squared plus 2x plus 2x plus 4, simplified, x squared plus 4x plus 4. Really close, but I started with x squared plus 4x plus 1. So this isn't quite right, so I'm going to adjust it. My goal is to have x plus 2 squared with a number. I'm going to rewrite what I started with as y equals x squared plus 4x plus 4, which is this guy. Take away 4 at the same time and adding 1. So, knowing the goal I have in mind, I have forced this equation by adding 4 and taking away 4 at the same time, which doesn't change a thing, which will allow me to write these 3 terms as x plus 2 squared, and these 2 terms as my leftovers. These 2 are equal, but look very different. I know my vertex from this one is minus 2, minus 3, and I know my y-intercept from this one is a 1. That is called completing the square, and we need to practice. Let's do the second one. I'm just going to rewrite it so we can write one right under the other. Okay. For completing the square, I know that my goal will be to have x and a number squared. Last time it worked very well for me that I used half of 4. That works every time. So I know my ultimate goal is to end up with x minus 4 squared. So I always leave a line and go back up to my second line and say, x minus 4 squared is actually x squared. If you can't do it in your head, do it off to the side. X minus 4 times x minus 4, which is x squared minus 4x minus 4x plus 16. This is minus 4 doubled from outside inside. This is 4 squared from last. Those are the numbers you're thinking about. So if I go back to the second line and rewrite this a little differently, x squared minus 8x, I'm going to introduce a 16 and subtract a 16 at the same time, take away 5. My line 1 and my line 2 are equal. I have added 16 and subtracted 16 at the same time, which doesn't change its value. That allows me to take the first 3 terms, x squared minus 8x plus 16, and write those as x minus 4 squared. The last 2 things, the minus 16 and the minus 5, I can put those together in a pile and end up with minus 21. Those 2 are equal, but they look rather different. So in summary, completing the square, this is what I do. Number 1, I write down my goal. It is always half of that middle term. which is we call it b, half of b goes into the bracket. So it's going to be x minus 3 squared. That's my first job. My second job is to go back to line 2 and add and subtract this number, this half number, squared. So I'm going to use that specific number. So I'm going to add 9, subtract 9 at the same time, and put it into my old equation. So x squared minus 6x, I'm going to add 9, subtract 9 at the same time, and just put that into the middle of my equation. So I haven't changed it, I've just added some stuff. Returning to my third line, I'm going to collect the x squared, the minus 6x plus 9. That would go into the bracket, which I've already written. So those three things are really this. And then I add the leftovers. Those, minus 7. I have completed the square. Y equals x squared minus 6x plus 2 is equal to x minus 3 squared minus 7. 3 more. I did a couple of really ugly ones here so that you can work your way through it with me. The first one, we have a negative here, which is really, really awful. I take my negative out first and do my process after that. So when I factor out a -1, I change the sign of everything there. Now I'm going to pretend that negative and those brackets aren't there at all and do completing the square as I did it on the previous page. Y equals negative. Leave some space. I skip a line and I go to my goal. My goal, this is really a nasty one, will always be half of the middle term. So my goal will be x plus 2.5 squared. I know that I want to introduce whatever 2.5 squared is, adding and subtracting that to line 2. Add, subtract whatever 2.5 squared is into my equation. 2.5 squared is 6.25. So I am going to write my function and add and subtract 6.25. There we are. Those first three things is that. Then I will put the leftovers together, which is minus 10.25. I have completed the square. It's ugly, but I have it in brackets exactly like I did it on the last page. However, I have that negative sign out the front. So to make it look truly like vertex form, I am going to distributive law to get rid of the outside green brackets. Then it will look exactly like vertex form. So negative there, my first arrow. Negative times negative is positive when I do distributive law on the second arrow. There we are, vertex form. The vertex is minus 2.5, 10.25. It opens downward with a regular step pattern. I couldn't have gleaned all of that from the original form. Let's try the second one. This one is also ugly because it has a 3 at the front. My first thought would be, is there a greatest common factor for all three of these? 3 does not go into 38, however, so it is not a greatest common factor. We're going to have to factor out the 3 and then complete the square. So the 3 is the ugly part. I'm going to factor it out. x squared plus 8x plus 38 divided by 3 is 12 and 2/3. There. Now I'm going to do my usual procedure on completing the square, ignoring that 3, pretending it's not there. So my procedure is to ignore line 2 for a moment and go down a step to my goal. My goal is always half of that second term, which is an 8. So my goal will be x plus 4 squared. In order to have that, I need to insert or add and subtract into my function whatever 4 squared is, which is 16. So I'm going to take my original equation and introduce a 16 and a negative 16. There we are. The first 3 terms, x squared plus 8x plus 16, is my x plus 4 squared goal, and then I put in the leftovers. Minus 16 plus 12 and 2/3 is 3 1/3. Minus 3 1/3. That's not quite vertex form with that extra set of blue brackets. So because I factored out a 3, I'm going to have an extra line at the very end where I do distributive law with the 3 to make it look like, there we go, vertex form. Y equals 3 x plus 4 squared. Subtract 3 times 3 1/3 is 10. Lastly, one with a fraction. We have a fraction of a half, which is going to be rather painful. We're going to factor out the 1/2 first and then complete the square. To factor out a half, I need to make sure that when I do distributive law on my second line, it will look exactly like my first. So I actually put larger numbers into the bracket so that when I have them, I get what I started with. Then for completing the square, I'm going to skip a line just to be careful. Write down what my goal will be, which is always half of the 6. X plus 3 squared is my goal. In order to force it to look like that, I need to introduce whatever 3 squared is by adding and subtracting it to my equation. I need to add and subtract a 9, which doesn't change anything, so that the first 3 terms give me x plus 3 squared, and my last 2 terms leave me with a minus 5. I've completed the square, but it doesn't quite look like vertex form. I need to do distributive law with the half, which will leave me finally y equals a half x plus 3 squared. Distributive law, a half times minus 5 is minus 2 1/2. There, I have vertex form. Completing the square is going to take some practice. You're so lucky that I gave you so very much. Page 153, 3, 4, 7 to 11 and 13. And course notes 26, 1 to 3, 5, and 6.